That solar panel powering your neighbor's house for the next 25 years? It started as nothing more than a handful of beach sand. The same stuff kids build sandcastles with becomes technology that captures sunlight and turns it into electricity. How does something so ordinary become extraordinary? The answer involves temperatures hotter than lava, precision measured in atoms, and some of the most incredible engineering on Earth. Every year, humanity produces enough solar panels to power entire countries. This $200 billion industry now generates electricity cheaper than coal in most of the world. And it all starts with engineering at the atomic scale, turning the planet's second most common mineral into humanity's most promising energy source. We begin with quartz sand, found on every beach in every desert. But here's the engineering challenge. For solar panels, this sand must become 99.99999% pure silicon. That's so pure, a single grain of table salt would contaminate an entire batch. Think of it like finding one typo in every book in the Library of Congress, except the typo is an atom. To achieve this, arc furnaces blast quartz with 50,000 volts at 1800 degrees Celsius, hotter than molten lava. These furnaces run continuously for 200 hours, consuming as much electricity as a small city just to produce a few tons of ultra-pure silicon. The result? Silicon cleaner than anything found in nature. Next comes something that looks like magic, growing massive silicon crystals. Engineers use the Chokroslavsky process. A tiny silicon seed gets dipped into molten silicon and slowly pulled upward, spinning at exactly 20 RPM. Over 30 hours, this seed grows into a single crystal weighing 200 pounds, with every atom perfectly aligned. Imagine spinning a candy apple until it's the size of a person, but every molecular layer must be flawless. Why perfection matters? Because electrons flow through aligned crystals like water through a straight pipe. One misaligned atom drops solar panel efficiency by 15%. Each crystal costs $50,000. Diamond-coated wires thinner than human hair slice these giants into wafers just 180 micrometers thick, thinner than 2 sheets of paper. One vibration during cutting ruins a $25 wafer. Here's where physics gets incredible, turning silicon into an electricity generator. Wafers enter diffusion furnaces at 900 degrees Celsius, where phosphorus atoms penetrate exactly 300 atoms deep, no more, no less. This creates an invisible electric field inside the silicon. When sunlight hits, photons literally knock electrons loose, and the electric field pushes them all in one direction. It's like installing millions of tiny solar-powered water wheels, all working together. But here's the problem. Pure silicon reflects 35% of sunlight like a mirror, wasted energy. The solution? A silicon nitride coating exactly 70 nanometers thick. That's 1,000 times thinner than paper. This coating traps light like a spider web traps flies. That's why solar panels shimmer blue. Now they need to collect the electricity. Screen printing machines apply silver paste lines just 100 micrometers wide, 5 times thinner than human hair. These are highways for electrons, and they must be perfect. Thick enough to carry electricity, thin enough not to block sunlight. It's like drawing electrical maps with a pen so precise, one tremor ruins the entire panel. One solar cell generates 0.6 volts, barely enough to power an LED. So robots connect 72 cells in series with zero resistance loss. Temperature tolerance? Plus or minus 3 degrees. Too hot cracks cells, too cold creates resistance. Then comes the protection sandwich. Cells get laminated between tempered glass and weatherproof backing, vacuum sealed at 145 degrees Celsius. This package must survive hurricanes, hailstorms, and desert heat for 25 years. Every panel gets torture tested, blasted with artificial sunlight stronger than the desert at noon, then flex tested 2,400 times to simulate decades of wind loading. Only 98% pass. The scale is mind-blowing. Modern factories produce one complete panel every 3.5 seconds, 24 hours a day. Each panel contains components from 12 different countries, assembled with robotic precision that detects defects invisible to human eyes. Here's what's incredible. The best commercial solar panels today achieve 22.8% efficiency, remarkably close to silicon's theoretical maximum of 29.4%. That's like catching nearly a quarter of all the energy in sunlight. But engineers are breaking this barrier. Laboratory panels using multiple materials now exceed 47% efficiency by capturing different wavelengths of light simultaneously. The energy payback? Just 1.3 years. After that, each panel generates clean electricity for 24 more years. That's not just engineering, that's physics working in humanity's favor. So next time you see a solar panel, remember, you're looking at 15 million atoms of beach sand, arranged with atomic precision, engineered to capture photons that traveled 93 million miles from the sun and convert them into electricity that powers your life. From sandbox to rooftop, it's the most beautiful example of turning the ordinary into the extraordinary. And the best part? The sun rises again tomorrow, ready to power our world with nothing but light and human ingenuity. That's engineering making the impossible routine, one grain of sand at a time.